Okay, so we said this is called as continuity equation, right? थोड़ा सा इसकी spelling check कीजिए. We call this as the continuity, right? Okay, so then there's a definition of current density. The current density is, if I take this uh, conductor, right? Say this is some cross-sectional area A, right? So the electrons which are moving through this cross-sectional area, right? So this is some cross-sectional area A, right? So current through area A is called as J. This is called as current density. This is a new definition. So I is so J is dA by di by dA. Okay, so di equals to I dot dA. Okay, so see, if you tilt this area, this cross-sectional area, the product will be different. This is J. Okay, so I equals to integral surface integral J dot dA. dA or ds, differential surface area, whichever you like. Okay. Then we come up with the definition of scattering and drift velocity. So drift velocity can be calculated from scattering time tau. Scattering time tau is the time taken by an electron to make a collision and then make a secondary collision. So time taken between two successive collisions is called as scattering time. Remember, if we have this conductor, if you have this conductor and the electrons is moving and strike some molecule, okay, strike some molecule, the electron may get scattered. Okay, so may scattered here, but again since we have very strong electric field, right? So the electron will again find its path. After scattering, it will again find its path to move, right? So if this is the V plus minus, there's an electric field. Okay, so there's a force on this electron. Force on electron. That force is Coulomb force. Coulomb force on this electron, right? So F Coulomb on this electron is going to create, that Coulomb force is going to create acceleration in the electron. Okay, so Coulomb force is QE, charge into electric field intensity, and M star, this is M star is the effective mass of the electron, a little bit higher than its free space mass. So the acceleration, you can calculate acceleration from this equation. Acceleration is the Coulomb force, F Coulomb divided by, acceleration is F Coulomb divided by effective mass. That's the acceleration equation. Okay, that's the acceleration equation. See, so so we have this equation. Consider this equation, and we move few definition on the towards the few definition. So what's the velocity? The velocity is equal to the acceleration multiplied by the scattering, because that's the time, the scattering time. That's the only time in which the electron is moving effectively in the direction against the electric field. So that's why you consider only this time, the scattering time, because that's the time when the electron is effectively moving. That's the time when the electron is effectively moving uh, that probably it again makes a collision for this molecule again. Okay, so it will again may get scattered and may again get velocity. So the time between two successive collision is actually the time in which the electron is getting its velocity. So velocity is acceleration time, scattering time. Okay, so if you put things in this equation for the value of acceleration, velocity is now this equation. Okay, and we call this as the drift velocity. We call this as the drift velocity. Okay, so drift velocity is the charge, electron charge. This is the electron charge. Why electron charge? Because we know that it's only the electron which is moving in the conductor. There is electron charge, scattering time, and effective mass. And it's the drift velocity which is actually constituting a current I. It's the drift velocity which is constituting the current I. Okay, so this parameter Q is a constant thing. Charge of the electron is constant. QE is how much? 1.6 into 10 to the power minus 19 coulomb. So it's a constant. Okay, it's a constant. Tau is almost constant at some temperature and for specific material like copper. Okay, so tau will be constant. Like we know that it's 10 to the power minus 14 seconds in copper. It's nearly 10 to the power minus 50, 10 to the power minus 14 seconds in copper. Okay, effective mass also depends on the density of the material. So it's almost constant for copper, constant, a different constant for aluminum, different constant for gold, and so on. So this entire thing QE tau m star is constant for specific material at specific temperature. Okay, and we call this as the mu, mobility, the mobility constant. Okay, we call this as the mu. So drift velocity is mu times electric field. Okay, remember, if you increase the charge, if you double the charge, uh, mobility will increase. Interestingly, mu is proportional to tau. थोड़ा सा इस कंफ्यूजन को खत्म करें. अगर tau हमारा बढ़ता है तो मोबिलिटी क्या होगी? मोबिलिटी बढ़ेगी. Okay, it's a good thing. So that's why I remove the red color and I put the green color here. Okay, so if tau is increased, mobility will increase. अच्छा, mobility क्या चीज है? मोबिलिटी अगर बहुत ज्यादा है तो इसका मतलब है रेजिस्टेंस क्या है? कम है. एग्जैक्टली, इलेक्ट्रॉन बड़े अच्छी तरीके से मूव कर रहे हैं. लेकिन अगर मोबिलिटी कम है, इसका मतलब इलेक्ट्रॉन बहुत ज्यादा कोलिजन ले रहे हैं. ठीक है, तो रेजिस्टेंस हाई है. तो रेजिस्टेंस हाई है. तो अगर देखो, अगर टॉ ज्यादा है तो इसका मतलब क्या है कि दो कोलिजन्स के दरमियान टाइम क्या है? ज्यादा है. तो इसका मतलब है कि कोलिजन्स क्या हो रही है? कम आ रही है. कम कोलिजन आ रही है तभी दो कोलिजन्स के दरमियान टाइम ज्यादा है ना. ज्यादा टाइम के बाद कोलिजन हो रही है. समझ आ रही है? तो जितनी कोलिजन्स कम होंगी उतनी, जितनी कोलिजन्स कम होंगी, टॉ is more when collisions are collisions are less. ऐसा ही है. Okay. So now again there's an Ohm's law of the conductivity, and that Ohm's law means J क्या चीज था? J क्या था? करंट डेंसिटी. ठीक है.
यस सर.
और रो वी क्या है? वॉल्यूम
चार्ज डेंसिटी.
चार्ज डेंसिटी. और वी क्या चीज है? ड्रिफ्ट वेलोसिटी. ओके. तो ये हमारे पास क्या है? ओम्स लॉ. बेसिकली ओम्स लॉ ही है ये. ठीक है. समझ आ रही है? कंडक्टिविटी, इसको हम कंडक्टिविटी भी
यस सर.
कहते हैं, और इसको वेलोसिटी. वेलोसिटी की हमारी अपनी इक्वेशन है. तो देखिए ये जो हमारे पास ये वाला वॉल्यूम चार्ज डेंसिटी का पैरामीटर है, ये क्या है? ये एक चार्ज इलेक्ट्रॉन का उस वॉल्यूम में, एक चार्ज, और इनटू एन. एन इज द टोटल नंबर ऑफ चार्जेस इन अ वॉल्यूम. तो रो वी क्या बना? एन क्यू ई ना. एक इलेक्ट्रॉन का चार्ज मल्टीप्लाइड बाय एन नंबर्स, टोटल नंबर ऑफ चार्जेस. ठीक है. समझ आ रही है?
यस सर.
और v क्या चीज है? फ्रॉम द लास्ट पेज, v is v is this equation. Okay, v is this equation. So v हमारे पास ऑलरेडी नोन है. तो n q e square multiplied by tau divided by m star को हम क्या कहते हैं? उस मटेरियल की कंडक्टिविटी कहते हैं. उस मटेरियल की क्या कहते हैं? कंडक्टिविटी कहते हैं.
कंडक्टिविटी.
ठीक है. तो हमारे पास क्या बना? J इक्वल्स टू सिग्मा ई, इक्वल्स टू सिग्मा ई. देखिए ये करंट डेंसिटी है. ठीक है. ये कंडक्टिविटी रिसिप्रोकल है, रिसिप्रोकल है ऑफ रेजिस्टिविटी. ठीक है. और ये क्या है? वोल्ट्स पर मीटर. ठीक है. ओम्स लॉ क्या है? V इक्वल्स टू आई आर. दोनों लॉज एक दूसरे के एक जैसे है या नहीं है? बल्कि एक ही लॉ है. ठीक है. समझ आ रही है बात की? सो कंडक्टिविटी क्या है हमारे पास? ये दिस इज कंडक्टिविटी. अगर नंबर ऑफ फ्री चार्जेस बढ़ेंगे तो कंडक्टिविटी क्या होगी? बढ़ेगी. स्कैटरिंग टाइम बढ़ेगा तो कंडक्टिविटी बढ़ेगी. इफेक्टिव मास रिड्यूस होगा, इफेक्टिव मास बढ़ेगा. इफेक्टिव मास अगर बढ़ेगा तो कंडक्टिविटी.
Nah, neta gue udah dial tamu orang kan dan ini kita akan dial lah white color dah use sih kan. Ini gue udah jen. Nama mau sekolah aku dah nama sekolah. Ini tuh di phone kan lah. Ini gue udah dah.
Okay, so we have this particular equation, right? Now look here. See, if the effective mass is more, conductivity will be less. You see, you need to consider all these parameters. Effective mass is more, conductivity is less, and so many things. Okay? समझ आ रही है? Any question here? This is the continuity of the current, right? Any question here?
No, sir.
So I guess I shall stop here, and we'll
Yes,
continue
sir.
with
आज के लिए बहुत
the
है.
same phenomena from tomorrow. Okay.
Yes, sir. इंशाल्लाह.